Okay, so it's 5 minutes past the hour, so I'll start on the next part of the course, which is Pandas data frames. So we looked at tabular data, and in the process we used Pandas data frames, but now we're going to look at Pandas data frames in more detail. A data frame is a collection of series, which is another class. The data frame is the way Pandas represent a table, and series is a data structure that Pandas use to represent a column. But Pandas is built on top of NumPy, which gives Pandas some power in being able to do statistical analysis of the data that it reads in from files and manipulates and so on. And it's a really good interface with tabular data, as you saw in the last section. So we're going to look at how to select parts of the data, and we're going to keep with this Gapminder data archive. And we're going to look at how to access the data using numeric indexes. And this is using something called dataframe.iloc. And we're selecting the values by their entry position. So in this snippet of code that we've got here, we're importing Pandas as before, and then we're reading in the Europe comma separated variable file, and we're doing iloc 0, 0. So what that means is what those two zeros are doing is they're selecting the country, and then they're selecting the year of that the GDP was measured. Can anyone guess what 0, 0 will, which data it will return you? That's fine. But 0 is a clue that it's the first country name by in alphabetical order. So it's probably going to be Albania. And the second 0 is the first GDP measurement made, was at 1952. And so that's what here you're showing the equivalent example using the lock method of the data frame class. And with lock, instead of specifying a numeric index, or it's a label. So that's much more readable. So that's clearly Albania and the GDP per capita in 1952. As with Python lists, we're doing slices. You can use this notation also. So if you did something like this, because you've got just a colon there and no min or maximum bound, you're going to get returned the GDP measurements for all of the years, which you can see below. And similarly, if you did the same, you focused on one year label, 1952, you then get the GDP per capita 1952 for all the countries. So it's just showing you the two main ways of extracting small parts of the data using index variables or numeric index variables or labels. We've got something here that's a bit more complicated, where we're accessing those countries, Italy to Poland, listed alphabetically, and then 3 years worth, well, I would say 3 years worth, over almost 12 years, well not quite, over 10 years actually, that's 3 specific measurements, 1962, 67 and 1972. So you can see here, though, that when we're doing data frame slices, or name slice, as it's called, it's not quite the same as what we saw earlier when we were doing numerical index slicing, I suppose, in that we had things when the minimum bound was inclusive, but the maximum bound was exclusive. So you go up to 1 before the maximum bound. Here, it's not the same. Both the min and the maximum part, when you use labeling like this, a name slice, both the min and the maximum, I think, are inclusive. So we've got Italy and Poland, not just Italy up to Norway. And similarly for the GDP measurements also. So the result of a slice can be used with further operations. In that is also a data frame in its own right. So we can just get a particular slice for a particular set of countries, for a particular set of measurements, and what's the maximum GDP. And so we have that. And then we can also obviously return the minimum too, if we're interested. There's other things we can do. We can use comparisons to select data based on the value. So here we've got the same subset, and now on that subset we want to return those data points where the GDP is greater than 10,000. I assume it's in dollars, I guess. So we're finding out where the values are large, and what we get. We don't get this, by the way. That's not what we get. That's when we print the subset data. We get the same kind of format, same table, but we just get a false and a true, depending on whether or not the GDP is greater than 10,000. So we could do so if we get a frame full of Booleans. It's sometimes called a mask because of how it can be used. And then, so in this one, where we were doing, we've got our subset, which is a data frame, which was worked out here. So we extracted a particular subset called the country and GDP year. But then we've got our mask, and we're doing something quite powerful, I suppose. That's just a logical expression, and we're just assigning that. We're just using that as an index, and then it's going away and returning those values for GDP that are greater than 10,000. And if it's less than 10,000, that mask is evaluating to false, so it just returns not a number, which means we don't have a number there. It's less than 10,000. So we get the value where the mask is true, and not a number where it is false. So this is useful because the not a number is actually ignored by the other built-in functions that you use, like max, min, and average, which it means that you can then just straightforwardly do a maximum over here or something similar. So we've got we can also do a print and describe. So that's when we're doing all of these operations on data that's returned, the mean, standard deviation, and so on. But everything is broken down by the years that are included in the subset. So there you have. So in these expressions, the values of GDP that go below 10,000, that are below 10,000 or equal to 10,000, will be ignored. So now we can talk about how we can group things. So there are various vectorizing methods and grouping operations. So let's say we want a clearer view on how the European countries split themselves according to their GDP. We may have sort of a glance. We can split countries in two groups: those who present GDP higher than the European average and those that are lower. And then we can estimate a wealthy score. So I think we do that by doing a aggregation, which is shown here. So we're dividing by the length, by the number of columns in the data. So we're working out the number of times that a country's GDP is greater than the average for its continent, for Europe. So if a country's GDP is greater than the average for every year that's covered in the data set, then its wealth score is going to be 1.0. And if its wealth score is 0, then at no time has its GDP been greater than the average. So this is the result of doing this. So you can see that there are certain countries that have always been greater than average. That's Switzerland and Sweden, and then some that have never been, such as Albania and Poland. And then there's quite a few actually that have never been greater than the average. But only, I think there's more that have a 0 score than have a score of 1.0. So we're going to, so finally for each wealth score table, we've only got 3 values, 0, 1, and, oh no, 4, 0.5 and 0.3. We can then group, we take the data and group it by the wealth score. So if we just scroll up a bit to recap on what we've done, where did we get the data? We got the data originally is from the whole of Europe. I'll find where it is. Anyway, I forget that. It's going to go too far up. And then we're seeing when the data is greater than the data mean, and we're using that as a mask. And then we're doing a sum to see how often that occurs, and then dividing it, normalizing it by the number of years that we have over the time that the measurements were taken. So this is like 52, 57, 62, and so on. And then we get a normalized wealth score. So now we can sum over the years, and we can see, right, a little bit what you can see for the various years. Say if we pick one at random, like 1997, we can see that the wealthy countries contribute most, but then the not so wealthy countries a bit less. But oddly, those countries that have 0 wealth score contribute, have quite a large aggregate GDP, and that I think is down to the fact that there are just more of these countries, more countries with a wealth score of 0 compared to those that have a wealth score of 0.3 or 0.5. They're still individually they're poorer, but there's more of them, so they add up to a high number. So I had a quick go through this. We can just try a quick exercise. So here, we're going to read in a data frame, DF, which is from the Europe file. And what I want you to do is just to write the expression that's required to select the per capita GDP for Serbia in 2007. And if you can do that, and if you can then just tell me what the number is, and just post that in the chat. So what you might need to do is just to look up through the notes for the lock method. Yeah, that's correct. So Helen's done that. So I just, for those who haven't quite done it yet, so you use the lock method, as I said, and it's very easy because you can just use the labeling straight away. So, I mean, from that question, it's very easy to do. It might be a bit of a faff trying to remember the exact format of the GDP column name, but there you go, that's all right. Now, just a quick question about slicing. So these two statements here, will they produce the same output? Yes or no? So what, can anyone just answer that in the chat? Oh, damn it, sorry. I think I've messed up. I've ruined that one. I had the solution already. So, okay. I'll just check that the other yeah, I'm just going to, that's, oops. Yeah, okay. So what's going on here is it's simply showing you we've got these two methods for accessing data, for extracting a subset of the data, an iloc and loc. And iloc, the rules when you use numerical integer index values, it follows the scheme that's consistent with Python slicing generally, in that what's returned is that data that's at position 0 and 1. So up to but not including 2 for both the year and the country. Whereas when you use loc and you're using a named slice, it's inclusive. So it's Albania, Austria, and Belgium. And it's 1952, 57, 62. So that's there. That's there. You can see that there. Yeah. So moving on to reconstructing data, can we explain what each line in the following short program does, namely what is in first and second, etc. So I'll do the first one's quite straightforward. I'm reading the data for all of the countries and all of the continents. That's what first does, but can people tell me what second is? Does anyone know? I wonder if perhaps the answer is too obvious. No one wants to answer. So where I've got a mask in there, I'm saying where the continent column is equal to Americas, then I want to select that bit of data. So I'm applying that to all of the data, so this first data frame. And so what I end up returning is the countries in the Americas, the 20 or so Americas countries. And then the first thing I do, the next thing I do is I drop the data for Puerto Rico. And then I also drop the column for the continent because that's redundant now. The countries are all in the same column. And when I do that for this one, I need to specify an axis 1 as an ID for that. And then I can then write the results for just the Americas countries to a result.csv file. So that's what's going on there. So look at selecting indices. Explain in simple terms what IDX min and IDX do in the short program below. When would you use these methods? So maybe just copy that and paste that code into your Jupyter lab notebooks and see what you get. So there you go. It's doing something that's quite useful in that you can print the minimum, or the maximum, but you'd like to know which country or year that applies to. So for each column in data, IDX min will return the index value corresponding to each column's minimum. IDX max will do accordingly the same for each column's maximum. So here we'll do more of a practice here. So assume Pandas has been imported and you've got the GDP gapminder data for Europe. So can you write expressions for each of these? I'll just give you a couple of minutes to do that. So I think with this exercise, the hardest one is perhaps question 3. Or at least you might think so initially. Okay, we'll have a look at the solutions now. So the first one is, for all countries in 1982, well, that is a year that the GDP per capita was measured, so we can just use the appropriate label in there, and using it on its own, it will then automatically get that year's measurements for all the countries that are in our set, all the European countries. And likewise, when we do for Denmark, because we have to do things a bit differently here, we need a separate argument that we pass into this array slice to say that we want to select Denmark because we're using the lock method here, because we're choosing a particular, so that's already a column name, but Denmark, it's not, it's a row value that comes under the country column, so we have to use the lock method here. So that's for the country, and this will be for the years, and because it's any year, we will just use the colon without any values either side. Now, to do the GDP per capita for all countries for years after 1985, well, it's a little bit not obvious, because 85 wasn't the year the GDP per capita was measured, it was 82 or 87. But you can just do the same thing here. So you're selecting over all countries, and then you could just say, including, you're starting from the GDP per cap and 1985, even though that label doesn't exist, it won't throw an error. It will start from the column that comes after 85, which is 87, 92, 97, and so on. So we can show that happening. Go into here. I think I called it data. I did. So there, you've got for all the countries from 87 up until 2007. And then the other one, the last one, per capita for each country in 2007 as a multiple. So how much has it increased by? I think the GDP per capita increase for all the countries is just this. So again, it's as simple almost as the answer to the first question. I extract the ones for 2007, and then I divide by the ones for 1952. So this kind of is very easy, very natural. And I think this is a consequence of having built data frames, the Pandas data frames on NumPy arrays. Just see what that happens to see if there's any. I think all the countries, yeah. So it's all above 1. Now there are many ways of accessing a value or slice of data frame, as you've seen by a name or an index value. But there's lots of ways in which you can do that. And I'll just go through them here. So by name, as you've seen, you can do the column name itself, or then you can have it as a series or as a data frame. So you can sort of see how that looks. What do we get when we do? Looks in that. So we've got that just a tidier way of expressing it when it comes out as a series. It's a bit more, it's a bit more neatly formatted. And then you can do the same thing. You can transpose the data. So then these things would be the year names for when the GDP per capita was taken, and likewise. And then you can use numerical indexing using ILOC and so on. And then you can do things like you can use a mask. So that was accessing a single column. And then so then when you use a single row, that's when you have to use lock rather than just apply sort of square brackets to data itself. And then again, if you do transpose, you're going to use the column. What was the column name? It's now going to be used as a row name, and so on. And there's lots of variations that you can check and go through. And of course, you can select several columns at once, several rows at once. And so on. And I think here you can do subsets of rows and columns, both in index form or in label form. So lastly, we've got something called another kind of helper built-in function called dir, and that lists the methods and I think attributes. I'm not sure. I think it weighs at least the methods that are returned by a particular object. So my string here would be an example of a string object. So dir then lists all of the methods that can be called with this string object. And you can do the same thing for the data that you've returned before. So we can just go in here. So I think we can do it there. We've got some things that I think look like constants, and that they're all, well, they're supposed to be constants that are all capitals. And then we've got all our functions, all the methods that we can apply. And there's many of them. So you might want to say, what does true div mean? I've just seen them at random. And so we can do help data dot true div. Probably the thing you want to do next. And seeing all the methods that are provided to find out what each of them do. I think that's fine. Or what's that? Yeah, so that was, you could use dir to find median, and then that would just be a simple case of doing that to find the value that numerically speaking falls in the middle of, of the values returned, the one that's in the middle. So I'm not kind of, this section just ends with this question about Poland's borders and the fact that they've been stable since 1945. That changed several years and years before then. How would you handle this if you were creating a table of GDP per capita? I'm not sure you would, I mean, because if the borders are changing, the population is changing, but then your measurement is per capita, so it takes into account population. So I don't know if, I did ask Andy this question in the break. I don't know if he replied or not. I don't know if that's a question that needs answering, but if anyone wants to follow up on that, you can just see. I think there's something in the chat. yeah, so the characteristics of the country may change because, you know, depending on how the borders change, there may be a particular industry that then gets included within the country's GDP calculation. Yeah, so there's things like that. You may have to separate. You may have to have more than one Poland. Can you do a product between data frames? So what you mean is that you would do, say if you have an array of numbers and then another array of numbers, and then you do a piecewise multiplication. Is that what you mean? You'd say each element would be multiplied against the corresponding element in the second array. Only considering the numerical values. I think it will. Yes, I think there will be a way of doing that. We can probably. I think we'll experiment with that in the next break. So, yeah, because it's built on NumPy, and I know you can do that directly with NumPy arrays. But to put together an example of that, I'll wait until I'm planning to have the afternoon break sometime between 3:30 and 4:45, so we can have a look at that then. Okay, yeah, I think. Thanks, Andy. He's posted a relevant link in the chat, so maybe that query is already answered. Does anyone else have any questions about the data frames, the Pandas data frames part of the course? So if not, I'll move on to the next section, which is on plotting. Right. So this is where Matplotlib is quite wonderful, I think. I mean, Andy was saying earlier that his favourite library module was Pandas, but I think Matplotlib is something that I've used all the time, a lot of the time, and it's so easy to get into and start to producing professional plots. I mean, plots that you can put into a paper very easily. And it's quite impressive because there's so much you could do with a plot, so many tweaks you can make to it, and to be able to then come up with an interface that doesn't overwhelm you with all the knobs and buttons and levers is quite nice. So there you go. So the first thing with Matplotlib is to import a part of it called a sublibrary, if you will, called pyplot, and then you import that, give that an alias, the PLT, which then you can call the methods on that class and to do the actual plot and to put things together very quickly. So we've got a very simple example here. We've got an x-axis of time, maybe that's seconds, days, who knows, and then you've got position in kilometers, and then you do the plot basically. So you just pass in the time list and the position list, and it will just plot it here as a straight line. You can, with the plot, there are a wealth of other arguments which you can play with, and those arguments can do things to set the line type or to set the plot point. So you could set line type to null and then set plot point to asterisk, saying you can plot this data as 4 asterisks. And then obviously these parts just allow you to set the label for the x-axis and the y-axis. And I think I'm using my, let's see what happens when I do this in here. So I'll close this and I'll start again. So I've just imported it. I'm just seeing what I need to do in order to render the plot. So I do need to do a plot. Oh no, it took a bit of time. I was thinking it would do it automatically. There you go. So that's how straightforward it is. And so in Jupyter Notebook example, running the cells should generate the figure directly below the code. The figure is also included in the notebook document for future viewing. So you may be in a different Python environment. You may be at a terminal session and have an interactive Python session. So that's one you started where you just typed in Python. And then you might need an additional command to actually show the plot. So that will bring the plot up, that will render it in a separate window. So normally you'd have to be using something else, something like, I can't find it here. But there's a particular viewer that you might need. But anyway, that's what's it called? It's something that's what's required for X11 forwarding and things like that. If you wanted to, if you were say somewhere remotely on a HPC machine and you wanted to be certain that plot.show works. So we've got so this next example just shows you how to plot data directly from a Pandas data frame. So again, we import Pandas as PD. We get the data using the PD object, reading in the Oceana data file. And actually now we're going to bypass matplotlib entirely, and we're actually going to call, we'll get a data frame that's returned using the lock method, and we're just going to plot that. So we just extracted Australia, and we're automatically just going to plot GDP measurements between the years 52 2007. So that's all that's done. So that's quite straightforward there. Now you can do things like you can select and you can transform the data a bit. So what we're going to do now is take the transpose. So now our x-axis is going to be, well, it's still going to be the year, but our y label again also will be the GDP per capita. So we're going to plot with the rows as the x series, and then we're just going to have to label our countries here using a legend. So that seemingly is doing that automatically, in that it displays the legend there. I'll just, so up above it was just doing the years, and we didn't have it labeled such that it could show Australia against New Zealand. So this was the way we're doing the plot. We're forcing to select a particular country at the beginning, and in order to be able to do both countries that are contained in the Oceana dataset, we need to take the transpose. So then the rows are the columns, and we can then get Australia and New Zealand out. And then what were the columns? Well, we can then plot over the years along the x-axis. So there are different styles that you can do very easily, that you can switch between. So we can do something like a GG plot, and I think is that referring to the color scheme. And then we can say that the plot is going to be a bar plot, and we're going to do GDP per capita. And there you go. So that's the same thing as bar plot there. So you can see, looking at the data, that back in the 50s, New Zealand was beating Australia. And then, I mean, it's quite surprising considering Australia is a much larger country, they've got more resources. but I'm guessing here at this point, Australia's industries kicked in that extracted its resources, such as rare metals or coal, mainly, and then, well, New Zealand went into a bit of decline there. I don't know, and then basically Australia just opens up a lead. So we can get Australia directly, as we've done before, from the data frame, and then we can do things like we can play around with the line type, and there's the types of annotation that you can use. So we can do like a green hyphen hyphen. So we're going to do the plot like that in green color. Let's see. Where am I with this? So I just checked that I'm up to the same. Data PD, so I've not done my import Pandas. Import Pandas as PD. Yeah, my plot. So that should be okay. But I'm just saying, making the point that I'll probably do other things. Change that to blue. I didn't like that. That isn't, maybe that would do something. Okay. So it's not happy with, there you go, I can do that color. So maybe it wasn't as flexible. So that's like a continuous line. And that's to do it as dots. So notice I've got a bit of a problem with the labeling on the y-axis. So you would have to do some code that would strip away the GDP per cap and maybe convert what's left into an integer. I think there's an example of that coming up. So we can plot many sets of data together. We've got Australia and New Zealand, and we plot them in blue and green, and we label them for the legend. And then we can do things like we can label the axes and so on. And oh yeah, the GDP per capita is in dollars. So let's just do that. So we've got that example there. And then, yeah, so when it talks about the way that a legend was added, that was using the labeling. And then you can, if you're going through matplotlib, as has been shown here, you can, when you plot the legend, you can specify where it's going to be placed on the plot using this argument to the legend method. So upper left, lower left, and so on. So we can also do scatter plots, like this one. So there, I think for Australia and New Zealand, we're seeing how their GDP compares. So we can sort of see that as New Zealand's rose, so did Australia's. Pretty much, there was a time where you get a hint that there were times where they weren't correlated so much. So we've got a scatter one there, doing the transpose. So we're bypassing matplotlib here and calling a plot.scatter from within the data frame. So we've got this first exercise. So here we have to fill in the blanks below to plot the minimum GDP per capita over time for all the countries in Europe. So what would you do? So it's a case of what would you put into the blanks? So if you can do that, if you can have a go at that exercise, and I'll just wait a couple of minutes and you can see where everyone is on that. Oh, I'm sorry, yeah. Sorry, my language was a bit loose there when I said that Pandas bypasses matplotlib. What it means is it is doing matplotlib under the hood. It's your code that doesn't need to use matplotlib, so you're bypassing having to explicitly call matplotlib methods within your code, within your Jupyter notebook. Yeah, thank you. That was an important clarification. Okay. Does anyone have any questions about the Minima and Maxima exercise? So it's quite straightforward. So you're going to plot the maximum GDP. So you're going to see how the minimum also, and then you can see how the minimum GDP has changed over time. So the first blank, you just want min. Yeah, that's the function you want to call, and min will return a data set, and then you want to plot that, and then you want to label that as min. And then for the maximum, it's just the same, but where you've got min, replace it with max. And then there's, when you plot the legend, it's I didn't know there was a setting for the lock argument to best, so it independently works out where the plot line is going. That's quite handy. So there you go, that just shows you what you need to do. And here's the results. I'm just going to take this into my notebook. So I've managed, yeah, explain that later. What I need to do the actual. Take that to max. We'll just have a look at the data that's returned. I'm missing something. Data Europe. See what I've done wrong. I'm missing parentheses. Yeah, thank you. Yes. Yeah. So there we go. We get the idea that the rich get richer, and the poor get a little bit rich. They can go down a little bit too. That's interesting because I remember in the New Zealand measurements there was a dip round about this time too, sort of in the late 1980s. But then there's a slight rise for the minimum GDP. Really, I mean, we don't know anything about the countries. So, I mean, I imagine this is Albania and this is Switzerland. But I guess which country had the minimum GDP would have changed. One thing I wanted to point out when I was doing plots quickly, you may have noticed that my x-axis labels were a bit of a mess, and that was just this little thing that I needed to do. So you go into your data set, you get your columns, and then this in a string form, and then you strip the prefix that the GDP per cap, and then when you've done that, you've got a years list, and then you can just convert that into an integer and pass it back to the columns attribute of your data set, so that when you come to plot it, you've got some nice years rather than text and plot upper column text. And you see with this, I haven't removed the prefix, and so what we did then, when we called xticks, we passed a rotation argument to say rotate the label 90 degrees so that it's vertical. Okay, so so it says close that one. Another exercise here. I'm just seeing how many more there are. We can do the next two. So we modify the example in the notes to create a scatter plot showing the relationship between the minimum and maximum GDP per capita among countries in Asia for each year in the data set. What relationship do you see, if any? So if you can do that, and I guess the first thing, if you went back to this code, you'd obviously have to replace Europe with Asia. So I'll give you a couple of minutes to do that. So if you're interested to know how to do a scatter plot, there's an argument called kind, and you do kind equals open quote, scatter, close quote, single quote. You pass that to the plot method, and that will give you your scatter plot. Okay. I think I'll just show you how it's done. So it can be done in quite a compact way. I think there's probably more than one way to do it. So yeah, thanks. I think Andy's just copied the data frame plot, or the equivalent of the info page. I assume a link to that. So obviously you open the Asia data file, but you get your data Asia and you can do the describe. And if you remember, describe returned the kind of basic statistical properties of the data set. So your median, your means, your min and your maximums, and how it's quite, you can then get you take the transpose, so then you can access the mean and the median and so on as column values, and then you can just plot those. And I think you're just going to use those labels out of the describe results, and then you can just obviously indicate that it's a scatter plot, and then you plot. So you've got the minimum GDP per capita on that side, and then the maximum, and you obviously don't know the year that these measurements were taken. And so you can see there isn't really, I mean, not surprisingly, there isn't really a correlation here. You can see as far as the maximum GDP, there's quite a range, and less of a range. I mean, there's quite a bit of bunching as regards the minimum GDP. There's a few countries that have a slightly, or a few positions where the minimum GDP is slightly higher. So it's not possibly surprising, because you think Asia is a huge continent and the countries within it are going to be quite diverse. We could do something else. We can then look at where these maximum and minimums are occurring. So we can look at where the maximums are occurring in terms of year. So we've got the variability in the maximum GDP. We got a sharp drop shortly in the 1970s. And I'm thinking, from memory, that will be something to do with the production of oil or the restriction of oil, and so fewer sales were being made, and so GDP dropped. Just another point, that the country with the lowest GDP in Asia is Myanmar, but the one with the highest varied more. The next thing I just want to show you is the correlations. This is a bit of a much more complicated plot, and so we're going to do a scatter plot showing you the life expectancy on the y-axis against the GDP per capita, and that's going to be a scatter. And what this is doing is basically, I think the question is, explain what each argument to the plot does, and I think hence the link from Andy Turner earlier. So if you can just try and run this code in your notebook and check that it works, and then if people can say, well, if people can answer, what does this argument do? What's this argument doing here? If people can let me know how that, the setting for that argument, what does it do to your plot? How is it changing your plot? And I'll wait. And the first person that posts an answer, assuming it's right, then I'll just I'll carry on with the rest of the explanation. So I'll just give you a couple of minutes to do that. Yeah, that's correct. It just resizes the marker. And what you're doing is you're taking the population and you're dividing it by 1 million, so it's in units of 1 million. And I can show an example I think I've done before. So here you notice that when I did it originally, I had it like this. And maybe it appears like this for you too. I don't know. I assume it probably does. And one of the things you might want to do is you might want to do something like, I don't know, remove the grid. You might want to change the color, the background color from gray to white. And you might want to know how you can do that. Well, there's also, you may also want to change the size. So there's just a bit of extra information you can do. Is in that example, you import matplotlib and you get pyplot as PLT, and you can set something called a style. There are many styles, and those initials B, MH don't really mean anything. I think it's from a data set called Bayes mastering for hackers or something like that. It doesn't really, it was just a set of style hints or style settings that were useful for this particular group. And when you do that, you can then also set these things. So it's just very, what I'm showing you here, it's just very, you can change a lot of things. It's very configurable. So I can set my edge color, I can set my face color, which is the background, to white, and then I can change it. And also, when I do the plot, when I do the plot that's within the data frame, calling matplotlib there, I can pass in an argument called grid equals false to turn off the grid if I wanted to. So that just gives you an insight into an extra bit of configurability that exists. You can Google matplotlib pyplot styles, and you'll find that there's many of them and lots of examples. So back to the course notes. Just if there was anything in here. Yeah, there's okay. And there's a message in the chat window from Andy to use Seaborn, another module library alongside Pandas. Oops. So, this last bit is just about how to save your plots. And you can do things like call the savefig method with the PLT and the pyplot object, and just pass in the name of the figure that you want to save, and it will work out the format from the dot extension you've used. PNG in this case, is that the portable network graphics? And so that will save it in your local, your current working folder, and you should see that appear within your within your Jupyter Lab window down here somewhere. You do that. And then there's you may need to do other things. Yeah, so saying that note the functions in PLT refer to a global figure variable after a figure has been displayed to the screen. So matplotlib will make this variable refer to a new empty figure. Therefore, make sure you call plot.savefig before the plot is displayed to the screen. Otherwise, you may find a plot with an empty. You may find a file with an empty plot. But that's quite straightforward to do. Just one further point about making your plots accessible. You can see that once you can save things, then it's quite straightforward to copy them into a paper or a presentation using LaTeX. You need to make sure that the text is always large enough for the font size and the legend and so on. Make sure that your graph elements are easy to use. line width, and beware of color blindness, or using lots of color, but maybe some people, your audience, might not be able to discern the different types of color. There's also a fact that for people who aren't, just for people with normal vision, and for people who are colorblind, I suppose, but more so in that when you have a rainbow, a palette or a color bar in the plot, you kind of, how sensitive your eye is to detecting changes in color, it changes over that spectrum. So I think if you can remember what a rainbow color bar looks like, you can see a big section in the middle of it where you can barely, which is normally green, you can't see any change in color. There is a resource that is really good that I found. It's very useful. It's this one. Whoops. Color. It's this one. It's called colorbrewer2.org. What it allows you to do, I'll just expand. So you can then decide what colors you have. If you want to have a sequential sequence, or one that is diverging, or one that is purely qualitative. As if what you are plotting, there isn't anything. They are different data sets entirely, say, if you were using a qualitative. But if you're doing something that was from a sub-ranges within a data set, you might use something like this. And you can do things like, you can say, I want it to, it's colorblind safe. And then you can obviously say how many I want. So if you do that, you can, if you don't like that scheme, you can choose another one. But that's something I found to be quite useful. Generally, I suppose, just try to be aware of overusing the color, and maybe think about other things like the plot point shape and so on. So that's that. I can move on to, which was just a lunch. I'll move on to lists. So hopefully we can finish before, well, not finish, we can have our afternoon break at about 3:45. So I'll just go on to the next one, which is lists. So we've gone from applications of what you would do in Python, some useful module libraries, library modules such as Pandas and Matplotlib. So now we're going to return to some of the basics of Python, and that's lists. So a list is just a collection of values. They don't necessarily have to be all the same type, but generally they usually are. So here, a list stores many values in a single structure. We can then do calculations on a collection of values, and it's just easier to manage them in a list. It's obviously easier to iterate over it and so on. So here's an example of a list. So we've got, so this is a list containing 5 elements. Each element is a pressure value of some kind. And you can easily just print that list, and you can obtain the length. In the same way, you can obtain the length of the string. And the indexing is also the same. So we go from 0 to 4. You wouldn't be able to index for that size of list. You wouldn't be able to. You get an error for trying to index position 5. And you can change the values of elements in the list. Straightforward. So if you want to change the value of the first element, just do that. Just do the 0 index. That's straightforward. And then you can change the list by appending values. So here you've just got an example where you've called list is an object, and you've called the append method on that list object to append the number 7. Yeah, and so as you can with string, and as we did with data frame, you can run help list to see all the things that you can do, all the methods you can call on a list. I think I'll go back. See, new. So list equals b, and so we've got lots of things. These methods that start with a double underscore, they'd normally not be called directly. So this one is actually called from the length built-in function, the len, which is what you've been using all the time. So that len, the len built in, will then make sure that you call the right length function according to the object that you're trying to find the length of, be it a string or a list or something else. And so you've got all the things you can do. You can reverse a list or remove an item or pop an item and so on. And we've got something called extend, which is similar to append, but rather than just adding one extra item, you can add on an entire list. And this is what this code snippet is doing. I've got my teen primes and my middle-aged primes. So primes is currently what we said earlier, 2357. Then I extend it with the teen primes. But if I then append, I get something maybe you wouldn't expect. But I get something that actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, has 9 elements in the list, because the last element is a list in its own right, containing 4 elements. So this is what the append does. Append always, whatever you're appending is going to be appended as one element to the array, or to the list rather, that you're calling append for. So this points to the fact that lists can collect values that aren't necessarily the same type. So I've got 8 integers and 1 list of integers. So it's a collection of heterogeneous value types, if you like. And so if I wanted to, I think actually, just to make things clearer, I think this will work. In primes, oh yeah, because I haven't got primes, have I? Primes is equal to 237. Going higher than that. 2357. So if I then wanted to that's that. If I wanted to access things in the last element, I'd have to use 2 index values. So what would be that work? No. So sorry, I'm wrong. Do that. So it's just, I'm just saying out when I did a prime index 0, that returns an integer, fine. When I do primes -1, that returns the last element in the primes list, which is a list in itself. So that means where it makes sense to then have that second index to get me the 37. So lists are quite a flexible data structure. So just going on to say that you can use the del built-in function to remove an element from a list. So you might think, well, I could just do a slice, couldn't I? So del primes 4. So I'm removing what I'm doing here is I've got my set of primes, which has got a 9 in it, but I've got my, I'm removing the prime at position 4, 0, 1, 2, 3, 4, so that's 9, which is right, this is what you want to do. There's a mistake. And then you do that, and you're actually changing primes. You're actually changing the primes list. If you were to do like a slice, let's go. So if you instead did, here if I change this, if I do this, I'm not printing. There you go. But I've not changed the original primes. The original primes is still as it was. When I do a slice, I create a new list entirely. There you go. So there's such a thing as an empty list, which is just a set of an open square bracket, closed square bracket, the 0 of lists. So that's usually a good value to initialize a list to. So this is, a list may contain values of different types, and so on. So we've got strings and integers. So character strings can be indexed just like the way that lists were. So we've got just a reminder of the string. Yeah, that's quite straightforward. Character strings, though, are immutable. You can't change them. So if you declared something as a string and then tried to change it, it wouldn't allow you to do that. It would have to be a list of characters before you could do that change. So element would have to be a list of characters rather than a string. Indexing beyond the end of the collection is an error. So yeah, you just get a simple string index out of range. So you can do this. I think as we're a bit pushed for time, I'll just skip through that. I'll just show you how it do. So we'll start with the an empty set. This is what values is doing. Okay. So if we set that to the empty list rather than the empty set, and we append 1, append 3, append 5, and we're going to get 1, 2, 3, 5. And then what we're doing is slicing. We're removing all. We're effectively removing the first element, so it's 3, 5, and we're assigning that to values, so we're overwriting values. How large is a slice? Well, it's because the start and the stop, because the list indexing is the same as the string indexing here. It's you go up to 1 before the stop. The size of the slice is stop minus start. So we can go from strings to lists. So we have a string, we can convert that into a list. We can then take a string, we can take a list. So we've got our list here, and we can convert that into a string. So what we're doing here is we're taking the empty string, and that is an actual object, and we're calling the join method on the empty string, and then we're just adding these elements in the list to the string, so we get gold. But if we wanted to, oh, wait a minute. So what we're doing actually, the join is we're specifying the separator as well. So list sum string obviously breaks that string out into a list, but the join, that will generate a string, but it will also use a hyphen for the as a separator. So when you have an empty string, you're basically indicating that you're not going to have a separator, and the letters in that list will just be joined together, just like as you would expect. So you can see that there in the join. So there's lots to do here. There's lots of other examples you can play with. So you've seen that the -1 will return the last one, the last character in the list. I think that kind of already covered how Python interprets a negative index. So -1 is the last one, -2 is the next, that last one, the U, and so on. So you can do things like you can delete, say, the last value in the list, and so on. So I'm trying to finish. I know I've got another part to do before the afternoon break. I'll see if there's any. I think I'll do one exercise. Shall we see? Tell you what, we'll do this one here, the stepping through a list exercise, where you start with an element. String is fluorine, and then you see what these statements do a print. So we're using something called stride. So we're using like a second colon with a third number. So if you just try those commands, try those statements in your Jupyter Lab notebook, and let me know what you get. Explain what stride does. Probably obvious from the name. Okay, can anyone tell me what the second statement does, the one that is in the square brackets, is colon -1. How does that, what do you see? How does that change fluorine? Does anyone know? Okay, so well, that's we'll start with yeah, that's right, it reverses the letter. So the one before that, this one is doing a stride of 2. So we're starting from the first one, but then we're skipping every other character. And so this one is, again, we're starting implicitly from the 0 index, but our stride is negative. So we're going -1. So we go, what that means is we go to the end of the string, and then we carry on going in that direction. So that's our solution. So you can see we've done F, we've skipped L, we've skipped O, and so on. And, yeah. I say the thing about slice bounds, again, I think we've done something similar with this before. So when an index is obviously beyond the bounds or out the bounds, I think it will just return the full string. In this case, so it's lithium is the upper, or the second statement rather, is going to be out of bounds, so it's going to return none. Because from -1, if you had -1 to -3, that would return something. But -1 and then 3, it doesn't. It's as if you started at the last and then you're going on. Not check that. That's an empty statement there. So the next bit about is that you can sort things. So you can easily sort a list. So in here in program A, I create a list with the letters G, O, L, and D, and then I run sorted on them, and then the result is sorted, I think. So my letters, I think, will be unaffected. That will be a list. That my result will be sorted, and I think that's still going to be a list. So program B, I convert gain gold into a list, and letters, I call the sort method on letters. So that's going to mean that that is sorted in here, but my result will be none. I get that right. I got that a bit different. So what the result, yeah, so my letters is as was originally, but it is sorted in alphabetical order, the result. When I call the built-in function as opposed to the method, that's belongs to the list class. So we've got another example here where we are copying or not. So we're doing a list again for gold, old, so that's returned into GOLD list, assigning that to new, and then we're changing the first one, we're changing the D to a capital D. It's quite simple. Doing the same thing again, but now we're taking a slice from the list, which is actually the full slice, and then we're changing the D again. So what is the, yeah, so there, that's what the difference is there. So new is always the same, doing the same thing, but the old will change in the first one, because we are pointing to the same object reference. That's what's going on there. So just to be clear, so this was a key thing that I'll probably talk about. This is something that I talk about in more detail when I talk about variable scoping. I've made this into a list, and then what I've done is I've copied the object reference from new to old. So then when I change new, that's going to modify old too, because I'm using the same object reference. And that's why then program A prints out exactly the same for new and old, even though I only changed it via the new variable label. Whereas program B, when I'm doing the slicing, I'm actually creating a new list. So new points to a different object, and then I change that. So that's why there's a difference there. But that's something we'll cover later. That's I think a bit of a subtlety for Python is argument passing, and you know how to see if it uses pass by value or pass by reference. So I'll cover that later. I think we've just got 5 minutes, and I'll try and do the first part of the for loops, and then I'll stop after that break. So with the for loop, oh, someone turned on. So with a for loop, it allows you to iterate over a list. So this is why the lists chapter was the one immediately before this one. And we've got an example here where we're just going to print every number in the list. That's straightforward. So we have a number of elements in our for loop. We have the collection, we have the body of the loop, and we have the loop variable. Now there are a few things that are key here to indicating a loop, and one is that the first sort of loop head, if you were, has to finish with a colon, and then the body of the loop needs to be indented. So how much you indent by. It just needs to be consistent. So if you had a for loop inside this for loop, the body of the inner for loop will need to be indented twice, if you know what I mean. That what in how much an indentation is, whether it's 2 white spaces or 4 white spaces or whatever. It's better to use spaces rather than tabs, because then spaces are will be interpreted consistently between different code editors. So here we're saying, yeah, the first line of the for loop must end with a colon and the body must be indented. So we don't, unlike my Hatch experience, if you use Fortran, you know that you need to use begin and end to indicate, or if you use bash or something like that, you need to indicate where the loop begins and ends. And then in C, you would use braces. So to always use 4 spaces, just to be absolutely clear. If you don't indent something, as you type it in, rather than, you wouldn't need to run this, as you type it in, the Python, well, the Python, the JupyterLab environment will pick this up and say, well, you've not indented it, you know, so on. And you can't just add in spurious indentation either. So these 2 lines should be starting at the same place. So you need to unindent last name equals Smith. So loop variables can of course could be anything. And I always thought this is quite succinct for kitten in the list, but kitten isn't particularly meaningful. We use something else. The body of a loop can of course contain many statements. We've got an example here where we're iterating over primes, and then we're squaring the prime and cubing it, and then printing it out. So there you go. So you have a print out for each element in this list. And I'll stop here and I'll break for 15 minutes. I tried to catch up a little bit. So I think that's okay. Does anyone have any questions? Probably won't have any questions about the start of the for loops, but do you have any questions about the list section and also the one before that, the one on plotting? If you could just post those in the chat if there was anything that you were not quite clear on. But we'll break in 15 minutes and start again at 4 o'clock. Okay, everyone. I'm going to start again. We just started on the loop section before, I think almost halfway through. So the next part of the loop section is the range built-in function. So that just returns a sequence of numbers, and so it will return. It's a bit similar to the array slicing indexing. So the example here that showed, you've got range 0 to 3. If you just had range 3, for example, it would assume that you're starting from 0. If you've got 0 to 3, it will take you up to 1 before 3. So 0, 1, 2, 3. So that's how it iterates using the range function. So here we're talking about something called the accumulator pattern, where we can initialize something to 0, and then we can just accumulate by going through a for loop. So this is what we're doing. We're adding up the numbers. Effectively, we're adding up the numbers 1 to 9. I think, sorry, 1 to 10, because in this range, number goes from 0 to 9. So that means that this will be 1 to 10. And so the result is 55. Yeah. So a quick question: is an indentation error a syntax error or a runtime error. Just type syntax or runtime in the chat. That's correct. It is a syntax error because it would detect it before you run. You can just try that now. If I just did 9 equals 2, and then I just did 9 equals 3, and then if I thought it would. So I actually had to, it is a syntax error, but I have to read the question. It says, so I think there's a mistake there. But other than that, other than maybe I'm doing something wrong, we can try again with a for loop. I can take an example here. So, but what if? And I don't know. So I'm having to actually, I have to actually run the code before I get to. I mean, it is a syntax error, but in order to discover it, I need to run the code that's in that code cell. So I discover it at runtime. So there's a slight mistake in the notes there. I don't know if it means, I think actually just being clear about it, I think what that means is it is a syntax error because before I run, so when I'm in here and I press Shift and Enter, when I run, it doesn't run immediately. The first thing it does is to do a syntax check. And that's what that is. So if I had a print 0 there, if I was actually printing something, that's how you know it's a syntax error that it's found when it's checked the syntax and not a runtime error. Because if it was a runtime error, it'd have at least done a print 0. So there you go. So that's just clear that up. So the next thing we've got here where we can create a table showing the numbers of the lines that are executed within this program when this program runs, and the values of the variables after each line is executed. So we're going to iterate through a string. So we're going to go through it 3 times, and each time we're going to add to total. So I think that's fairly obvious what's going to happen. We can start at 0 with char equals t. That's when we go into the loop, and when we go into the body of the loop, we add 1, and then we go to I, we add 2, and when we go to n, we add another 1 again, and we've got 3, and then we come out of the loop. So I don't think there are any surprises there. Is that clear to everybody? The next thing is about reversing a string. So what I'll do is I'll give you a couple of minutes just to like copy and paste that code snippet into a code cell in your own notebook, and then see if you just work out what needs to be done to reverse. So its result has got to hold a string that has the characters tin going in the reverse knit. Okay, so what we would need to do here is, again, we're accumulating, but the key thing, I suppose, is initializing the result correctly. So we just want to initialize result to an empty string. So that's just double quotes. And then when we accumulate results, we want to be clear about where the new char, this counter variable, is going to. Is it going to go to the start of the result string, or is it going on the end? So if we're doing it in the reverse, we want it to go on the end. Sorry, we want it to go at the start. So if you think, if you run through this, the first time is going to be char is going to be a t, and so we just have results is equal to t plus result. That result is an empty string at this stage, so we just have t, and then we have I is the next character, and we want result is equal to I plus result, which at this point in time has the letter T. So I think there you go. The char goes at the start. There's now just a few exercises on accumulating things. So we want to, I think in this one, simply add up the lengths of these strings. So we've got one's 5, one's 4, and another one's 3. So 7 plus 5 is 12. So that, I think, is quite obvious. Can someone just type in the chat what goes in the blanks? I think it's the same for both of them. Just so that I know someone's paying attention. So we want, what we're doing is we're adding up the lengths of these strings. So we need, total is going to have our length, so we initialize that to 0. And then we're going to just iterate through this list of strings. And so for each iteration of the loop, word is going to be an element in this string. So first of all, it's going to be red. And then we want to do is say total is equal to total plus the length of word, which is red. So total is 0 initially, so we just get 3. And then we have 5, and then we have 4. So there you go. Maybe that was that too obvious for people. And then the next one is we're doing lengths now. So I think we're doing a list of word lengths. So I think what we're going to be doing is we're doing a list ourselves. So in a similar vein, this will start with the empty list. So you have an open square bracket, close square bracket. And the word is going to go in here. So we're going to be calling a method on the lengths list. Can anyone tell me which method we're going to be calling? Just type it into the chat. Yes, appending. Just double check. There you go. Append. That's great. Yeah, I don't know if I missed this bit. You obviously have to. It's the word length we want. So not word in here. Did I just say just word? I think I just said word. We want len, open bracket, word, close bracket to get the length. You're appending the length into the list. The next one, where we concatenate all words, red, green, blue, like that. So I think that's going to be quite straightforward. So we set result to the empty string. So just have a pair of double quotes with nothing between them. And then we go for word in words. We'll just have result is equal to result plus plus word. So yeah, so that's right. Yeah, I think that's. So there's something else to create an acronym starting from that list. Create an acronym RGB. So what we can, as we're a bit, as we're a little bit behind schedule, I think I can just go through this myself. You may have an idea of what again, you're going to have to iterate through this list. And so you're going to have to start with each word. And what you would do is probably just extract the first element of each word, the first letter, extract it, slice it so that it comes out as a string, and just call the upper method on that string. And then the result of that is just concatenated onto the result variable. I think something like that one. Yeah, here we go. So this is what we've done. Yeah, so word, and then we've extracted that converts that into, I guess that's a string also, albeit a 1-character string, and then we call upper to return a new string where the first letter is uppercase. I'm just appending that. That's quite straightforward. So there's an exercise about indentation and making sure that things are indented. It looks like from first glance that you'll also have to rearrange things too. So reorder, yeah, reorder and properly indent the lines of code so that they print a list with a cumulative sum of data. That should be the result. So I'll give you a minute to do that. Just do a copy and paste that into your notebook. That should be quite straightforward to reorder and indent. So if the first person who does it just puts done in the chat, so I know when to move on. So I would say the first thing, these statements, cumulative to the empty list and total to 0, would definitely need to go outside before the start of the loop, so they don't have to be indented. And also this also needs to go outside the loop before the start of the loop, not indented. Has anyone done it? Yeah. Okay, so yeah, a few people coming back and saying so. So in case anyone hasn't quite done it yet, so you've got your 3 initializations that I mentioned that you need to do, and then obviously that loop is your start of your loop or number in data. Then there's 2 things that need to be indented inside it: your accumulator and then your append to cumulative. So there you go. So the next bit's about the sorts of errors that you can get. And these aren't specific to for loops or anything. So something called a name error. So you can read the code below and identify what errors are without running it. And then you can run the code and read an error message if you see one. So I don't know how many errors, there are 3. So looking at this, I think the indentation looks okay. What it's saying, it's not going to be a name error. So one error I can see. So what we're doing is we're iterating over a range, from 0 to 9, and we've got our loop counter variable called number. But then we're referring to a variable inside here called number, but it's not the same number. So I think it should be. So it says if when number is divided by 3, it's a multiple of 3 because it doesn't have a remainder. Then we add a. So I think I can see. So this is number with an uppercase letter when it should be number with a lowercase letter. That's the first thing. The other thing is message hasn't been initialized. So it needs to be initialized to an empty string before the start of the loop. And can anyone tell me what the third error is? I think there's only 3. I don't think there's another one. Okay, so we're trying to make a string. It looks like what this is doing is it's making a string of B's and A's. So A indicates a multiple of 3, B indicates that it isn't. So that, if you're doing a string, then that needs to be in quotes also. I think, yeah, okay, so those are the 3 errors. You could, of course, would have found this if you just copied and pasted and ran, and it would have told you. It would have actually, it would have found out when it tried to run and saw that that wasn't, that hadn't been defined. And also that A hadn't been defined either. Well, there's other things, errors, something called an item error. So we're doing seasons, spring, summer, fall, winter. Can anyone tell me what the error is here? Okay. To save typing then, yes, that's right. Listen, Max, you can't, the indexing only runs from 0 to 3, 0, 1, 2, 3, 4, so that's an out of bounds array access, list access, sorry. Seasons 3, you'd have to do all seasons -1. So those are the loops. Was there anything, any questions as regards loops? I'll move on to selection statements next. So that's if statements. So an if statement basically controls the execution path of the code. It's like it's like one of those gates you see when they separate sheep out on farms. Like a sheep can go to the left or to the right. It's that sort of thing. Most yeah, I mean if the if statement has an else clause particularly. So an if statement is more properly called a conditional statement. Controls whether some block of code is executed. So the first line is an if here, and like with the for loop, we end with a colon to indicate that this is going to be an if statement, and we have our if. We have the condition, which if this is true, then the body of the if statement executes. And this is simply saying if our mass is above greater than 3.0, then we print a message saying mass is large. So in the second example, we wouldn't because it's less than mass is less than 3.0. So yeah, you can obviously nest conditionals within loops, and you can nest loops within if statements also. And so here we can just do the selection statement and apply it to every element in this list of masses. And so there's only 2 that are greater than 3, so we have the 2 printouts. There's also the else part of the if block, which gets printed when the condition is not true. So that's quite straightforward. So here we would say if m is greater than 3.0 is large, the mass is large. If it's less than or equal to 3.0, then the mass is small. So that's quite, I think that's quite straightforward. You may, of course, have other branches in this statement because you may have like a high mass or medium mass or a very small one. So that's what we've got here. And in this situation, the order of the if clauses is quite important. So we're doing the same thing. We've got a list of masses. We don't really care what the units are. Well, they all have the same units. We can assume that. And so we iterate through the list for m in masses. If it's greater than 9, it's huge. If it's greater than 3, it's large. And then for anything that's less than or equal to 3, it's small. So it's important that we have these branches in the right order. So if say we had if m greater than 3.0, and then we had if m greater than 9.0, then we would never get any large masses. Sorry, we would never get any huge masses because anything above 3, which includes anything that's above 9, would just trigger this branch. So a mass would either be large or small. So it's important to think about the ordering on this, on that type of if statement. And particularly in this example when we're doing grading. So the conditions are tested once in order. Ordering matters, and this is just making that clear. So this would be a problem, for example. So whatever, anything above 70 would always be a grade C. So grade is equal to 85 is grade C, when really we should have grade is B. Okay, so another example with velocity. If the velocity is above a certain threshold, above 20, it's moving too fast. And then if it isn't, then we adjust the velocity, we set it to 50. Okay. And so we've got a conditional here where we're iterating through a loop, and I guess from 0, 1, 2, 3, 4, and we can think of those as time steps in a simulation, I suppose, in this situation. So we print out the velocity initially. If it's greater than 20, we're moving too fast, we would take off 5. If it's less than or equal to 20, we're moving too slow, so we add on 10. So you can see what it does in here in the output. Moving too slow, because we're not greater than 20 or equal to, and we're moving too fast. And we're still greater than 20, so we're moving too fast again. Moving too slow. So you can see that you would go around in a loop. Well, obviously you're going around in a loop, but these values of the velocity would loop round. I think because you'd go back up to 30 and then 25 and 20 and 30, 25 and so on. Can do things. You can trace a loop if you like. You can create a table. I don't know if this is an exercise to create a table showing variables values to trace a program's execution. The program must have a print statement outside the body of the loop to show the final value of the velocity, since its value is updated by the last iteration of the loop. Okay. Sometimes you may, within a selection statement, you want combinations of things to be true, and you can do logical combinations as you might expect, like logical and or. You probably do XOR. You do not also. So in Python, you generally spell out and, and you spell out or, and also not, NOT. In some languages, you indicate a not with an exclamation mark. In Python, you would spell not out as NOT. So in here, we're going, we've got two lists, a list of masses and a list of velocities, and we're just going through them, and we're doing selection statements based on what range the mass and the velocity falls into. So if something is fast and heavy, we duck. If it's not so heavy, not so fast, it's normal. Or if it's slow and light, ignore it. If it doesn't fall into any of this, into any of those bins, if you like, any of those categories, and we say something is up, and we check the data. So just like with arithmetic, you might need to use parentheses to double check what you actually mean. So you need to say what the order is. So I think by default, and has a higher precedence than or. So this as it is would execute this part first of all, and then if that evaluates to true, then obviously the whole thing would be true, this being an or, so it might not even execute that. But if it's false, if this and part evaluates to false, then you would need to execute that to see if you do indeed get a true, and then you have to go into the body of the if statement. Generally, it's good practice to be absolutely clear what you mean, and so if you want this to be executed first, you would put this inside a pair of brackets, such as it's been done here. So you might want to do this example. You might do the first two clauses first. So you need to put the brackets in place just so that it's absolutely clear. Just so that a reader later on, which might be yourself 2 months or so, knows that you definitely didn't forget to put the brackets in. So what does, here's an example here. What does this program print? We start with pressure, it's greater than 50. We set the pressure to 25. And then we come out there. So I think that's a bit obvious. I think that's going to print the number 25. Does anyone disagree? Did I miss anything? Well, let's see. It is 25. Okay, so we've got another example, another exercise here. So we have to fill in the blanks that this program, so that this program creates a new list containing zeros where the original list values were negative and ones where the original list values were positive. Okay, so I think this is something what we saw in the previous section. So result would be initialized to an empty list, square bracket, open square bracket, close square bracket. Then if we're going to iterate through the list, if value for value in the original, so if value less than 0, we append 0, and then if not, we do result dot append 1. So that's quite straightforward there. I think that's right. Yeah, less than 0, 0. So we've got one here where we modify this program so that it only processes files with fewer than 50 records. So I think by process it means that we only run this this print statement. Okay, so I'll give you just a minute to do this. If someone can just type in what you need to have in this blank space, but I guess you'd have to apply the length function to the contents variable. yeah. So the contents, when you run length on it, it will return the number of records in the data frame. So you just need to do if len contents less than, is it? Yeah, less than 50, fewer than 50. I think just check. Yeah, that's fine. That's very easy. So another one to modify this program so that it finds the largest and smallest values in the list, no matter what the range of values originally is. So we've got smallest and largest are set to none initially. So what do we think we can do here? I'll give you 2 minutes to work on that. So copy and paste that into your notebook. And if you just indicate in the chat what you've done. So in here, I mean, you can just add any numbers you want. Make them negative, make them positive. Just, 6 numbers will do. Okay, has anyone managed to do this? No. So the first thing in this part, you need to check. So what you're doing, you're perhaps not seen this before. So you're doing a multiple assignment on the same line. So you're saying to v, which is the v in this list of values, the first the first v actually, the first value, you're assigning to smallest and to largest. So this one you would put in there if smallest equals none and largest equals none. So you need to use the AND logical operator, and then else. So this would be called to the first element basically in the list. So then when smallest and largest aren't none, you would then go into the else body of this if statement, and you just then need to find out for the next v, is it smaller than the value that smallest is currently set to. So you'd have smallest in there and largest in there. So there you go. It's just that simple. That's probably the most complicated part there. There's some more notes about how you can make this easier, because the min built-in function, it can be passed a list as an argument, so that's much more succinct. But I think this is just demonstrating how to use an if statement. We've got something else here which is a bit leading into the next part of the course, where we've defined a function. So with loops, with a for loop, we'd indicate it with a for, with an if, and with an actual function we use def. We're going to define a function, and we also, again, we have a colon, and we have the name of this function, calculate life quartile, and then we have the arguments that we're going to define. So all this is doing, it's returning a number between 1, 2, 3, and 4, because as quartile implies, there's only 4 possibilities. So we're saying if this value is less than this threshold, we return 1, we're in the first quartile. If we're a bit higher, but we're less than 67, we return 2, and so on and so on. And then we're going to call this function, and we just pass it an argument, floating point argument, and then that returns 2. But we can do something that's a bit more succinct, in that we can actually, when we're using Pandas and we're obtaining our data frame, and then we obtain sort of values that are labeled life_QRTL. Well, actually, no, we're going to assign it to that. Okay, so this is what I mean. If we extract the life expectancies for 1952, we'll convert them into quartile measurement based on this. We can actually call an apply method, and the argument, rather than being a variable or some sort of data type, the argument is actually a function. This calculates life quartile. So you might think, well, where is it going to get its actual value from? What the answer is, where does it get its exp from? Well, it knows to call, so the apply method knows to call calculate life quartile with the life expectancies that are held from 1952 for all of the countries that were recorded across all continents. So there you go. There was one thing I thought I might just show about loops that I think was missed. You can have this thing where we can do for I in range 10. So just to recap, if I then did a print I, that would be quite straightforward. But if you had something like, if we're doing a list, say, so we had my list equals, and I'm just going to put, just put these in quotes so that they are letters or strings, and then I do ch in my list, and you can see what's it going to do. As you might expect, that sometimes if you have something that isn't, you might want to know the position of where you are in the array. That's quite handy. So when you do some code inside your loop, you might need to know the position. I should have done this earlier, but there's a useful function called enumerate, and what enumerate does is it returns the index of the current character that you are in the loop. So if I did print, I did 2 print statements. So what's that doing? As you iterate, so I print A, but A is at position index 0 in my list, and E is that position 4, index 4. So that being able to do that is sometimes useful to be able to know the index, the position within a list of the current item that you're working on. Okay, does anyone have any questions at the end of that loops and if statements part of the course? No, so I'm just going to see how much more we've got. Looping over data sets and writing functions and then variable scope. I think these sections do get shorter. I think the course is scheduled to end at 5 o'clock, but I'm happy to carry on until I've done the all of the exercise, all of the content. So that may be sometime between 5:30 and 6. Does anyone have to leave at 5? I think I'll just carry on anyway, just for the purposes of the recording. But I think I explained earlier, was it? There was someone who asked a question earlier. So the course notes. Okay, so Andrew, who's helping me, would need to leave at 5 p.m. But that's okay. I think the level of questions is fine, is manageable for just myself. But I just want to let people know that I will carry on until I've gone through all of the course. That everything is actually available in the training materials repo. So I'll just paste a couple of links in the chat. So that's for the ARCHER2 that go in. Yeah, so you've got lots of courses here for different types. And then the one for the last one that was done the last time that plotting and programming with Python was held is here. I'll just post that link also. So if you have to go, it's no worries. Once you have more time, you can refer back to the course materials. And also, I mean, I'm talking about not just the materials which you can access here. So this is all the actual notebook material, but actually the recording of the tutorial of the course also, and with audio. So that's all here. So you've got one for the time that it was done in April. Probably the next day, the recording that's being made now will also be made available also. So you can just choose which instructor you prefer to listen to. So I'll go on to the next section now, which is looping over data sets. And now, as you might think, so we've got here, we import pandas again, and we can loop over 2 data sets, the Africa one and the Asia one. And we're going to just print the minimum for each. So that the first time, for each year, we would print the minimum GDP per capita for the African countries, and then for the Asian countries. So that's quite, you can see that. We're going to break things down a bit more. There's a new library module that's not been this glob, .glob. It's a little mysterious, but what that allows you to do is allows you to specify paths using wildcards. So in Unix, the term globbing means matching a set of files with a pattern. And the most common patterns are you have an asterisk, meaning 0 or more characters, a question mark, meaning exactly 1 character. So any 1 character can go where you see a question mark, and any number of characters, in theory, can go where you see or 0 characters can go where you see an asterisk. So Python's standard library contains the glob module to provide pattern matching functionality. So where you might want to use this, if you wanted to print all of your CSV files in the data directory, you would do this glob.glob. So what that does, is apply, it finds all of the files that exist within a data folder that have the dot extension .csv. So because ARCHER2 matches with 0 or more, if you have a file that's merely .csv, then that will also be returned, that will also be printed. But what this does is it prints, all of the countries and then the separate continents that are represented. If you match something like PDB and there isn't anything returned, you just get an empty list. Fine, that's fine. Use glob and for to process batches of files. So what's going on here is this will be returning a set of files. So you have the one for all, Americas, Africa, and so on. And then it's going through that set. So the first file name will be all. And then what it's just doing a print of the minimum of GDP per capita over the countries that's recorded. So you can see for Gapminder all is the same as the result printed is the same as for the Gapminder Africa dataset, which tells you that the country that had the lowest GDP per capita in 1952 was in Africa. And then you have Americas and Asia and so on. So here's a quick exercise for you. Which of these files is not matched by the expression here, which isn't matched? So remember that asterisk maps is 0 or more characters, but any characters. So just type in a number in the chat. I think it's going to be 2. I think there's 2 examples that fit that mask. I don't know about 1. Did you say 1? Because when I look in Gapminder GDP Africa, I can't find the letters A and S aren't together. So unless you were saying 1 is the one that it, oh sorry, which of these files is not matched? Yeah, that's right, 1 is correct. Sorry, I didn't read that. Yeah, so 1 is not matched, but 2 and 3 are. So we can modify this program so that it prints the number of records in the file that has the fewest records. So I'll leave you to have a quick go at that if you just do a copy and paste. So I think the key to this exercise is just knowing what to initialize fewest to. Okay, so does anyone know how you would initialize the fewest variable? It's something that's may have been covered in very briefly, but probably not pointed out directly. It's probably covered, you probably might have seen it on the slide when we were talking about the not a number value that can be assigned to floating points, and that would be ignored. Yeah, I'd be, unless you're already quite familiar with Python, which in case you wouldn't be attending this course, but the key is to set fewest to something called INF, which stands for infinity or infinite. So that means when you're trying to find the number of records, or was it the number? Yeah, find the number of records in the data set, and you're going over all of the data sets that are available. You are going to read, you'll need to do a comparison here between, you need to do a min. So you get your data frame shape.0. So the 0 index in the shape is telling you the number of records in the data set. And you compare that with fewest. Well, if it's already set to infinity, then you already know that the first time that this is called, you're going to be returned the number of rows for the first data set, which I think, well, it might be all, might be the gapmind underscore all, and then you're safe from that point on. The other comparisons will be valid. So I think the data set with the smallest record is going to be Oceania. So yeah, there you go. It's set to, actually, it's a bit more than that. You have to do a float. You have to use a float built-in function and pass in the text INF. No. So what INF is a shorthand meaning infinite. So your setting fewest is just a floating point variable, and you're setting it to a number that is as large as can be. So it means that when you iterate through the set of CSV files, the first file that you read, the number of rows it has isn't going to be infinite. You would have run out of space on your hard drive probably. So it is going to be a finite number. And so that means that the first comparison that you do in the first iteration of the loop is a valid comparison. And actually, it's just going to return this. It means it ensures that fewest is set to data frame.shape index 0, whatever is that index 0, the first time this loop is iterated. Okay. So I think I'll just show you the solution to this. So we've got one where we're comparing data. We write a program that reads in the regional data sets and plots the average GDP per capita for each region over time in a single chart. So here we're going. So we're going to use glob in order to do our pattern matching on the CSV file names, and we're going to get matplotlib. And what we're doing here, I think we can just, maybe I'll just do that. For plots, what are we missing? Plots and plots. Log the file name. Might be, so those were just warnings, sorry, those are deprecation warnings. So here's the actual plot. And we notice we haven't done any tidying up of the x-axis labels, but I explained how that can be done. So we're just showing you how the mean GDP, so we're looking at mean here from the data frame, and showing that how that varies for each continent over the years. So we can see that for Oceania, it goes up the most, the mean. And then for, say, Africa, it increases the least. And I think this fact that the green line is highest here is an artifact that we have two fairly wealthy countries, New Zealand and Australia, whereas with Europe, I mean, yeah, it contains wealthy countries, but also some quite poor ones, and that applies even more for Americas, some of the countries in South and Central America. So that is just an example of what you are doing there. So with the region, with this slightly complicated thing, you're doing a split on the underscore character, and then you're extracting the last part. So if you remember, you had a GDP something underscore and then the year. So you basically split that according to the underscore. So the year would be last on the list. How can I explain how that works? So this is what this is. So if I had a string, it's equal to run 789, say. And then I did string split. I'm going to split that on the I just want to print that. That's what that's doing. That's just returning me a list, and so it's using the underscore as a separator. So if I then wanted to print like this, I'm just going to print the last number that's in the list, which is, well, sorry, the last part of that list. So it's what comes after the underscore. So that's what's going on there. You're just basically making sure that the region has a tidy name. So that's just, so the legend is quite clear. We've got one last bit, which is about using the path module. So you can pass it a path, and then that can be broken down into a parent, which is the outer directory, the folder that the file exists in, the stem, which is basically that part, and then the dot extension also. Thank you, Zoo. So there's still some people here. So are there any questions about this part of the course? And I'll move straight on. Okay. So we've got a reflection exercise. So we'll just, after you coffee, we'll just skip through that. The next one is when we write actual functions. So you would have seen a function that we did where that was something where we were working out the life expectancy quartile number, and we used the def keyword. So it's obviously very convenient to break programs down into functions. And so it allows you to reuse code. It allows you to encapsulate complexity and just treat it as a single thing. You've seen elsewhere that you can pass a function as an argument to another function in order to execute that function over the elements in the list. So it's useful form of abstraction. So you've got a very simple function here, which is indicated with a def keyword, and then you need a colon, and you've got a pair of brackets there to indicate the arguments. In this case, we have no arguments, and so we're just going to do a print hello. And so when you define it, it's not going to run the function. It's just going to set up the function so that it'll be called later. So it's just going to check the syntax when you have that in a code cell, and then you just press shift and return. It's just done a syntactical check on there, or parsing to check that the code's okay, And then if you wanted to actually run it, you'd have to then do the call separately and then run this code cell, and then it goes like that. So the arguments in the call are matched to the parameters in the definition. So you specify the parameters here, and I think in this print date, it's assuming that they're all going to be integers, as it's passed into string functions inside print date, and then you call print date, and you pass it the year, the month, date. So what's important here is the order. The order in which you pass things needs to match here, but there is a way around that. So you can name the arguments as you do the call. So you could say, well, I have month first. So if I do that, I have to know that one of the parameters I use to define print date is month, and I'll do month equals 3, day equals 19. So I can have any order I like if I name them. So functions may return a result to their caller using return. So that's what's done here. I'm being passed probably a list of integers, and then if there's nothing in the list, so this is a bit of a sanity check, a safety. There's nothing in the list and there's no average, I'll return none. But if there is, I then sum over the values, and then I just divide by the length. It's quite easy. So there you go. You might want to call the round function of this, and then if we're trying to do the average on an empty list, it would just return none, as is indicated by this if statement. So every function does return something. A function that doesn't explicitly return will always return none. So if you remember the print date, which is to the print, that would return none. And you would be able to print results, and that would be none. So we've got probably what is an easy exercise, and we have to read this code here and identify any syntax errors. So I'll probably just do this with you. Also, is it a syntax error or an indentation error? So I think another function print a string, that looks okay. I see there's an indentation problem here, which will happen before you call. You'll find out about before you call another function. And then that one looks okay. I thought, is that all there is? Repeats to another function. Oh yeah, there's errors to do with the way that the function header. So I'm missing a set of parentheses, and I'm missing a colon also. So I think that's all there is. Definition and use. You've got what we're calling something called report. That's been passed an argument, an argument called pressure, and then it prints it. So you see what this does. So a function call always needs parentheses, otherwise you get the memory address of the function object. So that's what's happening here. So what you need to actually do is when you're calling it, you need to do report open bracket 22.5 close bracket, and then you get the expected behavior. You get the printout pressure is 22.5. We've got a few examples here. What's wrong with this example? We're doing a print time. Can anyone tell me what's wrong here? Does anyone know? So it's just that it's out of order. So I'm trying to call the function before it's defined. And then the next bit, after fixing the problem, explain why running this code results in in this output? Well, I'm calling print time, so it's doing the print statement in here, and then, but I don't have a return, so it returns null. Sorry, it returns none. Yeah, it's defined, the function is defined after the call to do that. So we've got a few other quick ones here. Encapsulation, fill in the blanks to create a function that takes a single file name as an argument and loads the data in the file named by the argument and returns a minimum value in that data. So I'll give you a minute or two just to do that one. So the function needs to take in a string basically, but you can just call that string whatever you want, like file name. And then you can see you're doing an import pandas as PD. So you're going to use the read underscore CSV method from the PD object, and that will give you data. So just to show you what that is. So there you go. So it's quite simple. You can get the minimum value by once you have data, you just call data.min on that. It's another one to fill in the blanks to create a function that takes a list of numbers as an argument and returns the first negative value in the list. What does your function do if the list is empty? Okay, so what we might have for v in values, I can imagine if v less than 0, then we just return v. So because we've got a return there, we'll just stop going through the list. We've already found the first negative value. So can someone just type in the chat what happens if the list is empty? No one knows. So what this means, if the list is empty, you're not going to go into that loop because there are no values. So it will be, not quite, it returns a none, not a number. So it's as if, so basically, it will say for v in values, well, v values is empty, so it doesn't execute this loop. It just returns from the function without having to call return, because it only calls return if it finds a negative number. So when a function doesn't call return, the output, the return is actually none. So there you go. So this function again for printing the date. So we saw that you can call the function with named arguments like day, month, and year. So I think there might be a problem here. So it's saying, what happens if we do this? Well, I think each of these need to be a string. I wonder. Or is it going to be able to convert them? I think it might actually be able to do that. So we'll just try that in here. So we just define the function there. And now we just do a print. So I think, oh, Oh yeah, so I've no need to worry about that, because even though they're integers, I'm using the string in here to convert them into strings, so that's fine. The print date, I have got a problem though. Day, year equals, so what's it telling me? Struct object is not callable. All right, let's see. The order, yeah, I think there's a problem with the ordering. Because if you look at what it's saying that it should work, I thought it would. So I don't know what, I think I've done something silly in my code. Day is equal to 1. It shouldn't matter about the ordering because it's named. Something like this. Something more fundamental in here, I think. Joined, maybe it's yeah, it's looking like I had something wrong. Plus string month are these. Okay. So when you have a problem like this, I often just try and make things as simple as possible. I know. So I need to run that. I've still got the same problem. So if I'll just do a joined is equal to here. What am I doing wrong? So I think I've forgotten. Struct is not callable. I'm going to come back to that. I've done something a bit silly. I'm not importing something. Now, of course, where I want to just get a move on. We'll go on to the next exercise, which is encapsulating an if print block. So here we're doing a label printer for chicken eggs. So we've got we're importing random. We're iterating over a range 0 to 9, and based on that, we're going to call random.random, which will return a number between 0 and 1, and then so we get a mass that is I think, yeah, it's somewhere in the range 70 plus or minus 20 grams, and then we print it. So we're just having a selection statement which says what type of it categorizes the mass according to very large or medium and small, and so then we can just run that either like this, or we can take this bit and put it into a function called egg label mass. So what you need to do is to create a function definition for get egg label, and then you'll just do that, and then you should be able to then just go through this loop, and it will print out the mass times. So I'll just give you a couple of minutes to play with that. Yeah. Thank you, Jane. That's what I've done. Yeah, because I remember now, because I was doing something else. It's in my, I've killed my, yeah, that's exactly what the problem was. If I can just show you, where was I doing it? Down here, I have something else. Yeah, this thing. This is the offending line. Thank you. So now, I know we're doing the other exercise, but now I should be able to do that, and at least that bit works. Oh, I've still got a problem. Because, yeah, I wonder if I need to run that, because it's not enough just to delete that statement. I need to run that, and then no, it's still finding it. So the only thing I'm going to do is just close this down completely. So discard, and then I'll go on to the end of this just to demonstrate that. Can I get that to work? So this will be how it is. Right, and then there you go. So somehow it was difficult. I'd foolishly used str. So you shouldn't do that, because obviously it's a very commonly used built-in function. That was a mistake on my part to do that. Just tried to do something a bit extra. Okay. So yeah, that's positive mental attitude. So there you go. I don't know if anyone's been able to do this. I mean, it's quite straightforward in that you just need to put this, not all of this. You need to put this bit into its own function. So you can do that here. It's a little bit different because there's some extra things you can do in the notes. You have to make sure it's initialized correctly to unlabeled. And then if it's greater than 90, you might say that the egg is dirty. If it's less than 50, you might say, or if it's less than 25, too light. If it's less than 50, then it's too light, probably spoiled. So I think otherwise the else, I always think if you're commenting, sometimes I put a comment for the else block just to be clear about what value range causes this statement to be called. So it's not less than 50, it's greater or equal to 50, but less than 55 when it's small. So I might add a comment in there just to make it clear when that else branch would be activated. There's one bit here about assuming that the following code has been executed. So I'll go into this exercise. So we're going to import Pandas, and then we're reading the Asia dataset, and we extract Japan. We're interested in a particular year. So we're going to form a decade string. So we're interested in years reported for the 1980s. And then we're going to divide by 2. So I think we're going to try and get an average for 1980. So it's 1982 and 1987. That's right. So that's what we need to do. As we're running short time, I was going to sort of show how to do that. So we get a decade, and what we're doing here, we've got 1983. We're doing a floor divide. So what that effectively does, it takes 1983 and divide by 10, but it's converting that into an integer. We're doing a floor division, so we're rounding down to the nearest whole number. So we're going to get 198. So we're going to have this GDP per cap underscore, and then after that 198 in the string, and then we're just going to add 2, and we're going to add 7, and that will get the 2 measurements that we need that fell within the 1980s. And then having done that, we can divide by 2 to get the average. So there you go. The next bit is probably something I'll leave for a later exercise for people to go over. So that's quite, what you're doing is you're setting up a dynamic system that just is a function that describes the time dependent of a point in geometrical space. So you're going to have a loop, you're going to iterate over that loop, and you're going to call a function for each time step, and the time step returns the position. So it's just to get you more in. I'll have a quick look at this. Yeah, there's nothing that you've not seen before in terms of you're basically defining a function, and then you're going over a series of time steps. So you're in time step 10, 100, and 1,000. I think it's not. It looks like a population that you're plotting. So quickly, does anyone have any questions about the writing functions part? I'm just going to go on to the next one, which is variable scope. So variable scope is a bit more detail about how function calls actually work. So we've got something here where we have a variable called pressure, and then we have a function here called adjust, where we work out something called temperature, and we need the pressure here. So what's going to happen is that pressure is a de facto global variable now. Its scope is the entire code snippet, this section of code. So when adjust when the adjust function is called, it will know that pressure's value is 103.9. So it's critical that pressure is defined before the adjust function is defined. So that's what's going to happen when we call adjust with 0.9, and we get the temperature. We return the temperature, and then that comes back. So pressure is a global variable. T and temperature are local variables in adjust. Okay. So we would have to have that print would have to have been inside there, or if we're outside, we would have to have a call where we would have to receive the value returned by adjust into a new variable, which may be called temperature also, and then we can print that. So, or we could just do that, adjust, and then the return value will be automatically printed. Yeah, so it's saying that we wouldn't be able to do temperature because that's not defined outside the function. With temperature not defined. We've got local and global variable use here. We're defining a limit called 100. We've got our function, we're passing in value. And again, we're using limit because it's a global variable, we've got access to it. So we're assigning a value minus 22.5. We come into the value function. We're looking at the maximum of 0 and minus 22.5, which is going to be 0. So then we work out the minimum of 0 and limit. But we're going to get an error here, I think. Is that actually, I would expect. Let's see what that does. Oh, so that just returns 0, I think it would. We've got a quick section on here on reading reading error messages. We have something called a traceback, where it tells you, it basically unwinds the stack. So you might have a function call within a function call, and within that function call is where the error occurred. So it will kind of trace back along that call tree hierarchy. So we've got something called, this is where the error is in this example. We try to use day when I think day is set to Friday, and that's not a key in the messages list. Yeah, key error on Friday, and that's occurred inside this function. Yeah, it's here. The print message, print Friday message. So that there's one thing I think I'd like to cover, and that's to do with variable scope. There's a few things, because in computer languages, generally, when things are passed into a function, when you have a variable that's defined outside and then you pass it in, you often want to know, if I make any changes to that variable inside the function, will it persist once I've finished calling the function? And so there are various paradigms associated with passing in a parameter value or an argument value. And there's things such as pass by value, essentially you're doing a copy, and there's something called pass by reference. Now, pass by value is a sort of thing that you're seeing here in this in a code snippet. I have something called myvar equals 1, and then I've got a function called myfunc, and then when I call that with myvar, basically the value 1 gets passed to myvar2, but inside myfunc I set myvar2 to 10. So you can see what's happening here. Before the function call, it's 1, and then within the function, myvar2 is 10, but outside the function, myvar is 1. So this is like equivalent to a pass by value, in that changes that happen to parameters that were passed in from outside don't persist outside the function. There's another parameter passing paradigm called pass by reference. So this is when I would pass in the address. So here, when I call my func, I would be passing the address of my var. And so my var2 would now be using the same address as my var. So when I change my var2, that would also affect my var as well. So when I return from the function, my var would, the changes made inside my func would persist, and my var would be 10 too. So that's pass by reference and pass by value. What Python does is something called pass by object reference. And you might wonder what that is. Well, an object reference is just a value. So it's quite a subtlety with Python, and I'll try to explain what I mean. So what I've done, I've shown what will happen if I'm just using an integer type of variable. But if I did something where I had a list, say, instead, so my do, and then I did something in here. So I did my to, or perhaps I do, a bit of a longer list, and then I do that, and then I just try and run everything again. You can see it hasn't changed anything. It's as if it's a pass by value. But the key here is when I'm coming into here, the object reference is the same as that used for my var. But when I try to change my var2, I'm inadvertently, I'm straight away, I'm creating another object. So it's as if I've discarded the object reference that is used by my var, and then I'm creating another one, which is for my var2. So this assignment implicitly creates another object. So that means that changes made to my var2 in this way don't persist, in that after I've called the function and I print out my var again, I don't have the longer list anymore. But if I change things, if I did something a bit different, if instead I called append, or maybe if I did extend, and then I did, I don't know, 5, 6, 7, and then I run things, you will find that it's as if it was a pass by reference. So things have persisted, and that's because I've got my object reference for my var and I've called my func. That object reference is copied to my var2 as a copy by object reference. And now I'm keeping that same object reference. I'm calling the extend method on my var2. So I'm not creating a new object. And so by doing that, when I extend, I add these extra elements, those changes to my list will persist. So that's what's meant by pass by object reference. So if you're thinking of what's going to happen in my Python function, is it going to have a site? Are changes I make going to persist? Then it's because it depends really on how you make the change, how you change the value of the parameter inside your function. So that's, I thought, was something I would just cover as an extra. So moving on, the next bit is just about coding style and about being clear about documenting your code. And normally a thing that I would do whenever I add a comment, you can, as you've seen, you can indicate that a comment using the hash character, but you can also do it this way as well. And I also mentioned way back that you can also do an assert statement. So there was someone on the course who was saying, can I check later on that a variable hasn't by accident acquired an incorrect value? Well, this is the sort of thing you might do. You do an assert, and if that fails, that will interrupt your program execution and throw a runtime exception. You can do doc strings. So if you do your comment in a particular way, like this, for example, and then you run help on your average function, and the function called average, it will return that string that you've put there. And you can do multi-line comments in your code. You do it like this. So you start with a triple series. You start with triple double quotes, and then you finish it in the same way. So it allows you to have a comment every multiple lines. And again, this is just a simple exercise to show how you can comment some code. So for this exercise, instead of using the hash character, you would use this. And I think then that will be picked up by the help function. And then there's a simple exercise we do some clean up on this, which just means document the code, make variable names more clear. But generally, I find when I add a comment to annotate a line of code, I will, in the comment, I will describe things in terms of the problem I'm trying to solve, rather than terms of the computing language, because then that just makes it easy for the reader to understand, well, what is this line doing in the context of the problem? Because really, if you want to know what a line of code is doing in terms of the computing language, like I'm appending to a list, for example, well, the code it says tells you that that's what you're doing. You've got a method called append a list, which is clear that it's a variable that's also a list. So let's just a wrap up here. So we haven't been too late. So I'll just say, does anyone else have any further questions? Okay, I don't think anyone does. So thank you for staying with me. It's been a bit longer than expected, but that's okay. There were just quite a few more examples in this that take a bit of time to go through. I think in due course, probably might not be before the end of today, before 6, but might be early tomorrow. You'll be sent an email that will contain a link for you to give feedback. So thanks very much. Yeah. So I'll just hang about in case anyone has any questions or anything. So I'll wait until people leave the Collaborate session.